Welcome back, students of logic. Today we are going to talk about conditional introduction and conditional elimination. But before we go straight to looking at the rules, let's take a moment to review what the conditional is and how we use it. So if you remember, the conditional is the horseshoe. And the idea that it expresses is the concept of if, then. So if one thing happens, then another thing follows, has to follow. Or if the first thing is true, then the second thing has to be true. So a statement like, if it is raining, then it is wet outside, is a conditional statement. So we could express that, if R, then W. If it is raining, then it is wet outside. So when we look at that, there's a number of things that we can notice. First of all, the conditional is kind of like an arrow. It leads you from the first piece of information to the second piece of information. So if it's raining, then it has to be wet outside. But the arrow doesn't go the other way. If it's wet outside, maybe there are other explanations. The sprinklers are on or something. But we know that if this piece is true, then the second piece has to be true. So the conditional shows us that relationship between two ideas. Another way to think about it is kind of like a coupon. So say you're going through your coupon clippers and you find one that says, if you give the store money, then you can buy, a pound of apples or something. So $1 for a pound of apples. What does the coupon tell you? It says that if you provide the money, then they'll give you the apples in return. But it doesn't tell you that you have the money, and it doesn't tell you that you have the apples. It just expresses a relationship between the two ideas. So similarly, if you're looking at your problem, and somewhere along the scope line you have if A, then B. What that tells you is that if A is true, then you know B is true. It doesn't tell you that A by itself is true, and it doesn't tell you that B by itself is true, but it tells you that if you can find out that A is true by some other method, then you will know that B is also true. Okay, so let's look at the first rule, which is conditional introduction. All right, here is our conditional introduction rule. And what it shows us is that if somewhere in our problem we want to say a conditional statement, we want to prove that a conditional is true, so in this case, if P, then Q, what we need to do is demonstrate that idea. The idea is if P is true, then Q follows. Then Q is also true. So what we do is we experiment. Here's our regular scope line, and we don't know if P is true by itself. But what we can do is we can make our own assumption. So here we go. We assume that P is true to see what happens. So we draw a separate scope line. We write down that it's an assumption, and through whatever method we can, we derive Q, which is what the second piece that we wanted. So we assume P is true, and if we can get to Q being true based on that assumption, then we can assert that if P is true, then Q is true. And what we do to cite that is we put conditional introduction, or horseshoe I, which is we were introducing this conditional idea, and then we cite lines 1 through 3. In your own problem, it would be a different number of lines, but however many lines it took you on your added scope line. So in this case, it was lines 1 through 3, but it might take more or less. So that's what it allows you to do, to introduce a conditional, in this case, if P, then Q. You assume that the first part is true, and you try to derive the second part on a separate scope line. And in that way, you can assert a conditional statement. All right, so now that we've seen that one, let's take a look at conditional elimination, which will allow us to start with a conditional piece of information and eliminate it to get some information out of it. All right, now here is the conditional elimination rule. And what it tells us is that if we have a conditional statement on one line, this one says, if P is true, then Q is true. And then on another line, we have the piece of information that P is true, so the first part of the conditional is true. Then we can conclude that the second part of the conditional is true. So it says, if P is true, then Q is true. And then it tells us that P is true. So we know that Q is true, because it said if P is true, then Q is true, and P is true, so it follows that Q is true. And the way we cite this is that we put horseshoe E for conditional elimination, and then we say the two lines where we got the information. The line where we saw the conditional, and then the line where we saw the first piece of the conditional, which allowed us to conclude that the second piece of it was true. So an example of this would be like the rain. We know that if it is raining, then it is wet outside. And then say on line 2, it tells us that it is raining. Well, using this rule of conditional elimination, we can conclude that since it's true that if it is raining, then it is wet outside, and we know that it is raining, we can conclude that it is wet outside. So this is kind of like redeeming our coupon. It says, you know, our coupon tells us if we give the store money, then we can buy the apples. They'll give us apples back. And so we bring them our coupon, and we bring them on a separate line the money, then we can get the apples. So we're sort of redeeming the coupon. There's the whole coupon, there's the thing we give them, and then we get the W out in return. All right, and that is the conditional elimination rule.